So the answer for question 1 is 349.56 watt. So 349.6 watt. Then we go to the next question. So PA gap, how much PA gap of this system? So PA gap is equal to PA gap forward minus PA gap backward. The forward minus the backward. So we find out the first forward air gap power. So P equal to I square R. Now the I is your input current times R, which is half of the resistance impedance, which is RF. So I square times 0.5 RF. So I we have calculated, which is 4.789 times 0.5 times RF, and the RF that we calculate from the forward impedance, which is this one. That's why we need to write in terms of complex number as well, because we need this one. This is R plus JXF, RF plus JXF, and forward. So 2.161. 25.161, sorry. So we get 288.527 watt. So this is the PA gap forward. So what are the next air gap of the backward air gap? So PA gap backward. So PA gap backwards is equal to, same like PA gap forward, I square RB, which is half of the resistance. So I will use the same value of 4.789 square times 0.5 times RB, which is we have calculated just now, of 1.32 ohms. So you will get 15.137 watts. Then the PA gap forward minus PA gap backward. So this is the total PA gap produced to the system or to the shaft of the motor, which is 288.572 minus 15.137. You get 273.39 watts. So this is the total air gap rotation forward to the system. Okay, then we have to find the converted power and how much the converted power. So based on the flow power flow diagram, P converted power is the amount of PA gap minus the losses, or 1 minus S times PA gap. And so 1 minus 0.056 times the air gap power that we have calculated just now. So we'll get a lower in terms of amount of 259.72 watts in terms of converted power. So PA gap obtained, P converted obtained, and then then is your P out and output power. So your P out is equal to the converted power minus all the related losses that happen inside the system. But so far we are given that the system only have the rotational loss of 51 watts. So the converted power minus the rotational loss of 51 watts. So the remaining is 208.72 watts. So this is the rotational, the output power of the motor. Okay, next we have to find the induced torque, which is induced torque is equal to PA gap divided by synchronous speed and synchronous speed. So PA gap we calculate 273.39 divided by synchronous speed. So speed here we have to measure in radian per second. So we calculate in terms of how much rotation per minute, and based on the synchronous speed formula, which is Ns equal to 120 times F over P. So 120 times 60 divided by 4, we get 1800 rpm. So 1800 rpm per minute times 1 minute is 60 seconds times 2 pi radian divided by per rotation is 2 pi radian. So we cancel out radian with radian. rotation per rotation, sorry, minute per minute. So remains is watt per radian per watt second per radian, and watt second per radian. So or in Newton meter, the value in or the unit in Newton meter, 1.45 Newton meter. So this is the induced torque of the motor at the air gap, and induced torque at the air gap. Okay, next is your load torque, which is the output power divided by the speed at your mechanical or at your shaft, motor shaft. So we have calculate P out of 208.72 watts divided by the rotational in terms of radian per second, and radian per second, which is the rotational of the mechanical speed is 1710, and so you will get 1.165 Newton meter of your output torque or load torque. So how you calculate this 1710 of your mechanical speed is by 1 minus your slip value times your synchronous speed, and you have synchronous speed of 1800, so minus synchronous speed 1 minus synchronous speed slip, so you get 1710 rpm. So you put it here, so we get the load torque, which is much lesser compared to what being produced at the air gap, and because after air gap we have slip, so we take into account the slip, so the remaining torque at the shaft for sure be lesser than what produced in air gap, same as the air gap power and compared to the output power. So that's settled for F. And G is your efficiency. Efficiency means that the amount of your output power divided by how much you put into the system at P in times 100%. So we have calculated that the output is 208.72, input is 349.56, so times 100%, you will get your efficiency of 59.7%, and quite low because a lot of losses happen in between. And so also the power factor, which is cos theta, the angle of current compared to voltage, we got just now, which is 52.535. Negative means that lagging, so the power factor is 0.608, and so that's the power factor, and the efficiency is almost 60%. So that's settled for question 9.1 in example page 614, if I'm not mistaken. So we shall use this question for 9.3 as well. Okay, we take note on the load torque here, which is 1.16 Newton meter. This is the load torque and the full load torque. This is the torque at the induced torque, higher torque, but this is a load torque, means that when you operate at your mechanical speed, so this is the torque, and the torque produced at the load. Okay, let's say we have here the load angle. So this is your NS, synchronous speed. This is your mechanical speed. So it cross here. So this is your load profile. This is your load torque and load torque. And at this synchronous speed, for sure there's no torque. So the load torque happen here. Induced torque means that the power of your motor, the air gap power, for sure should be bigger than the load torque. And when we apply for the single phase motor, we shall apply starting mechanism of the mechanism whereby it can provide the higher torque compared to the load torque here. And if you start the motor without the starting current circuit, so you are not able to push push the load or push the shaft, and because the load already connected with this full load torque here. Unless your load profile is like this, and at certain speed, when the speed increase, the load also increase. So you can use this one, because at starting point, the torque already higher compared to the load requirement. Or let's say if the torque profile is like this, so means that the starting torque already higher compared to the starting requirement of your load. So you can still use the running coil instead of you put another auxiliary coil to provide the higher torque to the system. Okay, hope that's clear your concern on this motor. So we discuss 9.3 in another slide.